and 92 divided by 8 to give me 11.5. So again, looking at this thing here, which is again 11.5, this is your variance. So if they ask you for the variance, this is where you stop. This is what you give them, 11.5. Okay? So this is your variance here if they were to ask you the variance. And now, how do we finish if they ask us for the standard deviation? Well, all you need to do is take a square root of the variance, meaning whatever the result is the phi, you take a square root. So if you take a square root of this thing here to give you 3.39, meaning again, the average difference among your data from the mean is 3.35. Again, just think in terms of this thing here, your mean is 0, right? Your mean is in the middle, is 0, and you have -6, which is -6 below 0, and +6 is above 0, meaning again, those are 6 units above and those are 6 units below. And there are some in between, but the average difference among all of your data is 3.39. And again, the reason why we take a square root, is in step 3, we square each of your data, right? Because we square each of the data at the end, we have to take a square root, which is the opposite operation of the square. Okay? So this is what we have, or this is what you need to do in terms of the 6 steps. And again, I know if you look at this screen, you're like, oh, that's a lot of number. And is a lot of step, but again, it's very consistently the same. So if you keep on do it this way, which is I have this steps for you. If you look at this thing here, you will see that it's very doable. Let's do one more. Let's do one more problem. I know some of you probably have question, but let me do one more problem, and hopefully once we question. Try to see if I can do one more before I take questions, but go ahead.
Where did the number 9 on the step 5 came from? I'm sorry, I was trying to write the steps down and then
is the n. Number 5, step 5 is you have to divide by n minus 1. The n is the total number of data, which is how many individual data you have in terms of this thing here, which is you have 9 individual data. That's why I have 9 there.
All right, thank you.
All right. Let's take a look at another example. Hopefully this example is a little bit clearer, right? So let's say that we have this 2 example, right? Let's say that I ask you this thing here, which is I don't ask you for the variance, right? I ask you find the standard deviation for the data items in each of the sample shown below, right? So I have sample A and I have sample B, right? So again, I have to, basically the question is ask you, what is the standard deviation for sample A? What is the standard deviation for sample B? Okay? So this one here is just 6, so hopefully it's a little bit easy. This is what I want you guys to do, ladies and gentlemen. This is what I want you guys to do is create a chart. Okay, I have a small chart in a bit for you to see, but again, what is step 1? Reminder, step 1 is we need to find the mean, right? Because again, remember the standard deviation is the average difference from the mean. So if we don't know the mean, we won't know how far away from the mean we have. Which is again, first step 1 is we need to find the mean. So to find the mean, this is what we have, which is again, take each of your data, which is each of your individual data, add them up and divide by 6 because I have 6 total data here. So if I add them up, divide by 6, my mean is 78. Okay. So again, once you have this thing here, this is the chart, which is step 2. This is the chart I want you guys to create. Last time, the reason is I tried to put it in so that you guys can see what number I put in, but this is the chart you want to create, right? So this is what we have is I have my data, which is my data is 73, 75, 77, so on and so forth, right? And then step 2 is I need to find my deviation. So what is the deviation? The deviation is basically the data minus the mean, which is everybody see my data is 73 minus my mean is 78, which is again, my mean is that, right? So again, step 2, data minus the mean, 75 minus 78, 77 minus 78, 79 minus 6. And again, each of my data minus my mean. Okay, that's step 2. Take the data minus the mean. And now, looking at this thing here, this is where I mentioned to you guys last time is, if you were to add all of your deviation up, if you want to check your step 2, if you add each of this, -5, -3, -1, 1, 3, 5, if you add them up, it must be equal to 0. They will balance out. There will always be some data above, and there will always be some data below. And if you add them up, it's just 0, because again, the negative and positive, they each cancel each other out, that's why we cannot use this thing here to find the standard deviation, because remember, to find the average, we need to add the item and divide by the total. But if you add all the deviation is 0, you divide by 6, you still get 0, right? You won't get anything done if you were to do this, right? But again, just to show you that if you add this thing here, step 2, if you add them up is equal to 0, it's not that important. It's just always the case is equal to 0. Okay. Now, step 3, what does step 3 tell us to do? Well, step 3 tells us is whatever the result of step 2, whatever the deviation is, we need to square them up. So if I square them up, which is -5 squared to give me 25, right? -5 times -5 to give me 25, so on and so forth here, which is -3 times 3, -3, -1 times -1, 1 times 1, 3 times 3, 5 times 5. So again, that's what my step 3 is, which is take whatever the result of step 2, square them up. And now, what is step 4? Well, step 4, we need to take all of this item, the 25, the 9, the 1, the 1, the 9, the 25, and add them up. The summation of the deviation square, right? Which is, again, that's what you need to do in terms of step 4 is add your third column, right? If you make this short, whatever your third column is, you add them up, which is, if you add them up, this is what you have is 70. And again, once you have this thing here, step 5 come in, which is step 5 is you take the deviation, the summation of the deviation square, and divide it by n minus 1. What is the n? Which is, again, like last time, the n is the total number of data, which is in this case, the total number of data is 6. 6 minus 1 to give me 5. So 70 divided by 5 to give me 14. And again, what is step 5? The step 5 is your variance, right? The question not asks you for the variance. The question asks you for the standard deviation. So looking at this thing here, what is step 6? Which is step 6 is your standard deviation, which is how do you find your standard deviation? You take a square root the variance, which is the square root of 14, right? Which is 3.74. So this is what we have, which is again 3.74, which is this is your average difference. As you can see right here, you see that some data are below 5 units, some data are above 5 units. Some data is above 3, below 1, and above 1. Meaning there are different layers, but the average difference among all of them is 3.74. That's what the standard deviation is, which is the average difference. How far is each of your data? What is the average difference among all of the data from the mean, right? So again, that's what we have here, which is your standard deviation item, which is, again, this is the 6th step. And again, I know is tedious, but by no means is hard. Again, oops, sorry. If on your calculator there's a square root button on top of the x square, whoever doesn't have know how to find the square root button on your calculator, most of your calculator, the square root button, you have to either hit shift and x square or hit second and x square to give you that square root symbol. Okay, if you have problem with your calculator or don't know how to use this, send me an email or let me know and I can show you. But let's take a look at sample B. Sample B is a little bit harder. Why? Because sample B, looking at this thing here, and again, I purposely do this. Well, first of all, before we do sample B, let me ask you guys who question here. Sorry, I say